Good evening, good afternoon, good morning. Welcome to Philosophy of Chemistry. We want to discuss how the universe arranges itself. This is another video of philosophical challenging ideas that I think everyone should know. To start us off, I want us to talk about the mystery of a tree. I want you to think of a forest. Think of a specific tree. A tree can weigh several tons, but most of that mass did not come from the ground. It came from the air. At first glance, this seems impossible. Trees grow from soil, so we assume the wood came from earth, beneath. But physics and chemistry tell a different story. Through photosynthesis, trees pull carbon dioxide from the atmosphere. Using sunlight, they break apart the molecules, keeping the carbon and releasing oxygen back into the air. The carbon dioxide becomes the structure of the tree itself. It becomes the trunk, the branches, the roots, the leaves. Which means most of a tree's solid mass was once invisible gas floating in the sky. A forest is not built primarily from soil. It's built from sunlight, air, and molecular transformation. A tree is quite literally a solidified atmosphere. And that realization reveals something extraordinary. The world around us is not what it appears to be. What looks solid is often transformed gas. What looks permanent is actually temporary arrangement of atoms. And to understand how such transformations happen, we must understand chemistry. Imagine taking the whole universe, the whole of everything that exists, every mountain, every ocean, every tree, every animal, every human being, everything, and reducing all those things into their elements or the features that make them up and creating a single list. What would you have? Actually, that list exists, and you have already interacted with that list, only that maybe up today you didn't know what that list was. That list hangs in every chemistry classroom across the world. It was in your high school, possibly you had it in the university. And strangely enough, understanding that list changes how you see the world, how you see reality, how you see existence, and how you see yourself. That list is called the periodic table. You have interacted with the periodic table. Most people think chemistry is just equations, laboratories, and difficult formulas. But chemistry is much deeper than that. Chemistry is the philosophy of transformation. It asks, how does matter change form while still obeying the universal laws? How does invisible gas become a tree? How does food you eat, maybe chapatis, ugali, and meat, transform itself into muscle? How does stardust become a conscious life? These are chemical questions, and they are also philosophical ones. The periodic table did not just appear overnight. It has its roots. Its roots stretches thousands of years back. In ancient Greece, philosophers searched for the fundamental ingredients or elements of reality. What are the things really made up of? Some believed everything was made from earth, water, air, and fire. Others proposed deeper principles. Thales, one of the Greek philosophers, emphasized water. Heraclitus focused on fire and change. Anaximander spoke of apeiron, the boundless, indefinite source from which all things emerge. These ideas were not chemistry in the modern sense, but they reflected a timeless human question. What is everything made of? And I want you also to think about everything that you interact with. Are they made up of different things, or they are made up of the same thing? Are you made up of the same thing, like a cow, a tree, a building, a desk, your laptop, or is very different? For centuries, people searched the answer to what is everything made of. Then in 19th century, chemistry began to transform from philosophy into a precise science. In 1869, Dmitri Mendeleev arranged the known elements according to their properties and atomic masses. As he organized them, a remarkable pattern started emerging. Certain properties repeated again and again. The elements seemed to follow underlying order. Mendeleev's table was not identical to the one we use today, but it revealed something profound. The diversity of matter could be organized into a coherent system. Today, the periodic table contains 118 elements. Of these, 94 occur natural on Earth, although some exist only in tiny amounts. The remaining 24 were created by human beings in the laboratories and particle accelerators. From hydrogen, which is the simplest and possibly the first element, to the heaviest synthetic element ever produced, the table represents humanity's growing understanding of matter itself, of what you're made up of. And once we have this map of the elements, once we understand the periodic table, new questions emerge. What can these elements become when they combine? Everything around us is made up of elements. You are made up of elements. The phone you're holding in your hand is made up of elements. Everything around you is made up of the periodic table in a sense. Everything is made from the elements of the periodic table. And the periodic table has hydrogen, carbon, oxygen, iron, calcium, gold. In fact, the first 20 elements, many of us learned them in high school already. They describe a remarkable portion of the universe. Hydrogen is the first element, followed by helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Those are the 20 elements we learned in high school. I guess possibly you had a song or a formula to help you remember. I have my formula, which the shortness of the video does not allow me to go into it. These 20 elements alone help build the stars, planets, oceans, rocks, plants, and living organisms. The water you drink, the phone in your hand, the air you breathe, even your own thoughts happening right now as you listen to me and process this video. All of it emerges from a combination of these elements as the building blocks. And there is an even deeper story hidden behind the elements. According to modern cosmology, hydrogen was the first element to appear in abundance after the Big Bang. Inside stars, hydrogen fused into helium. Larger stars forged heavier elements, carbon, oxygen, silicon, iron. And when massive stars died, they scattered those elements across the space. In a poetic sense, all elements are children of hydrogen. Every atom in your body, it traces its ancestry back to the earliest moment of the universe. The periodic table is not just a chart, it's a family tree of cosmic history. And your body itself is chemistry in motion. You are not separate from the periodic table. You are actually a periodic table. You are an arrangement of it. Although the human body contains dozens of elements, about 99% of your mass comes from just 6 elements: oxygen, carbon, hydrogen, calcium, and phosphorus. So in other words, I could actually say that you are just made up of the 6 elements of the periodic table. Then you can add small amounts of potassium, sulfur, sodium, chlorine, magnesium, and iron. And you have most of the chemistry required to build a human being. Just think of it. You, as special as you think you are, you're made up of very few elements of the periodic table. Less than 15. There are 118. 94 are naturally occurring. It's calcium that makes up the strength of your bone. Iron carries the oxygen in your blood. Sodium and potassium help neurons and signals. So when medicine treats disease, it often works by adjusting the chemical interaction and balance inside your body. So treatment is basically trying to balance or rearrange the periodic table that you're made up of. In a very real sense, medicine is chemistry trying to restore harmony within chemistry. And even chemistry is not just confined in the laboratories or even in the hospitals. You encounter chemistry everywhere. Cooking is actually chemistry. When heat touches food, molecules break apart and reorganize. Part of that reorganization is what makes some food easy to digest and easy to eat. When heat touches the food, that rearrangement and reorganization helps proteins to unfold, sugars to caramelize, fats to melt, and new flavors emerge through chemical reaction, such that when you taste that food, it tastes differently from when it was raw. That is chemistry at work. That's rearrangement of the periodic table at work. A simple kitchen is actually a laboratory of transformation. And the same principles that built the stars, trees, and also built you help bake the bread and prepare the dinner you eat. That's the wonder of chemistry. And at the center of chemistry lies something called an atom. When you break matter into its smallest, not really the smallest, but it is its first smallest particle, it's called the atom. It will be broken up later into other particles, elements, other particles like the electron, proton, and neutron. But let's talk about the atom. Atoms rarely remain isolated. They bond. Some share electrons, some steal electrons from other elements. And in that exchange of stealing and sharing forms a giant metallic structure. This invisible relationship determines whether something becomes hard as diamond or fragile as glass. A conductive, or it becomes conductive as copper, or it becomes explosive as fuel. The properties of matter emerge not only from atoms themselves, but from the relationships between the atoms. One element became especially important for life, and that element is carbon. Carbon can form chains, rings, and enormously complex structures. This single property gave rise to protein. It gave rise to DNA. It gave rise to plants, animals, medicine, plastics, perfumes, and every living organism you have ever encountered. In other words, carbon is the base of life. Anything that has carbon has chances of becoming life. Remember the tree from the beginning of this video. It's made of wood. Wood exists because carbon atoms, once floating in the atmosphere, became locked into living structure. In many ways, organic chemistry is the chemistry of life itself. To study organic chemistry is to study life. But chemistry is not just static. Reactions constantly exchange energy. Some release energy like fire, others absorb energy like photosynthesis. And nature constantly seeks balance. It seeks chemical equilibrium. If you disturb chemical system, it adjusts itself to restore the equilibrium. The universe appears to resist imbalance. From ecosystem to cells, balance and transformation exist together. And then chemistry becomes even stranger. At the smallest scale, electrons do not move like tiny planets, even though the model to help us understand an atom paints a picture of electrons rotating around the nucleus as if they are small planets. That's not the case. Those smallest elements do not move like tiny planets. They exist like a probability cloud. And that's what we call the quantum mechanics. This quantum behavior explains why atoms bond the way they do, and ultimately why matter itself has structure. So chemistry quietly sits at the boundary between quantum physics and the visible world. The solidity of a tree, the taste of food, and the chemistry of life all emerge from the quantum rules operating beneath reality. And that's something to think about. The philosophy of chemistry reveals something even more profound, that reality is not static matter. Reality is continuous transformation. The universe constantly breaks apart and rearranges itself. It combines, it dissolves, and rebuilds itself. A tree becomes soil, soil nourishes the life, and life returns to the atmosphere. The cycle continues, and human beings learn to participate in the transformation. But chemistry also gives humanity enormous power. The same chemistry that creates medicine can also create poison. The same chemistry that feeds civilization can build weapons. So chemistry is not merely scientific knowledge. It becomes moral responsibility. To understand transformation is also to become responsible for how we use it. So the next time you drink water, cook food, take medicine, or hold your hand, you are witnessing the periodic table arranged into a temporary form. The oxygen in your lung was forged in ancient stars. The calcium in your bones was born in stellar explosion. And the carbon in your body may once have drifted through forests, oceans, and countless living creatures. You are not separate from the universe. You are one of the chemical expressions. And chemistry is the story of how the universe endlessly transforms itself through the arrangements. And therefore, to study chemistry is ultimately to study how matter learns to become everything. I hope you have enjoyed another video on philosophical challenging ideas that I think everyone should know.